Okay, so today we're going to discuss how to use point slope form. Point slope form is just a linear equation that goes right along with standard form, which we've talked about, slope intercept form, which we've also gone over in class, and now the third one, often forgotten, but never should be underrated, point slope form. The actual equation for point slope form is y minus y1 equals m times x minus x1. All right, and when we're going to be able to use this equation is when we're given a graph and we got to write a linear equation for a graph that we're given. Or sometimes instead of given the entire graph, we're given the slope of a graph. We're also given at least 1 or 2 points of a graph. So today we're going to discuss how to actually write out an equation, a linear equation, if we're given a slope and if we're given a certain number of points. So for this equation, you need 2 inputs, 2 things you're going to plug into this equation to kind of rearrange it and write a linear equation. One, you will need your m, which is your slope. You'll need to know the slope of the line. The slope of the line, whatever your slope is, will get plugged into the equation right there at that spot right there, right where the m goes. Second, you need a point on the graph. It can be any point on the line. Every single spot on a line on a graph has several points. It has an input and an output, or an x value and a y value. You can use any point you want. So this will be any point on a graph. Now, obviously, when we mean on a graph, we were talking about the actual line on a graph, not the graph in general. All right, so those 2 things. Now, these 2 points, you'll actually plug in with your y1, and you'll plug in with your x1. So I guess we can kind of say this is your x1 and your y1. And we're going to plug those 2 points in. So essentially, once we have this information, we're going to plug in our slope where the slope goes, x1 and y1 at their proper locations. And then we're going to kind of set it up and rearrange it and create a slope intercept form with it. So let's move on to an example. Actually, let's do the first example we're working on in class. M equals 5, which is our slope. And the point we're going to use is 1, 4. All right, so we have the slope of a line, and we have the point on that line. So we're just going to take this information, and the first thing we're going to do is we're going to substitute it into the equation. Now, you want to start out by writing the equation out every time, so that way you kind of get to know the equation, as well as it makes it much simpler to substitute or plug in information, because you know exactly where it's going to go. So first step, substitute. We're going to substitute the m. We're going to substitute our m and our x and a y. We're going to plug this information into the equation. All right, like I said, this first y is not affected by it. It's going to stay there. Minus. Here's my y1. Remember, this is an x value, and it's a y value. And for the time being, since it's the only x and y we have, we're going to call it x1 and y1. So my y1 is 4. I'm going to plug 4 into the equation. Equals. My slope is 5. So we'll write 5 into the equation. So far, so good. Now in the parentheses, that first x will always stay there because we always need an x and a y in a linear equation. We're going to need our input and an output. So we don't want to get rid of those. My x1, however, is 1. So I plug that in. So far we've substituted in our information. Second step, we're going to end up distributing through multiplying. So we're going to distribute by multiplying. Now, really what we're doing is we're going to follow the order of operations, or PEMDAS. But we can't do anything to the left side. I can't take away 4 from a y, so that's going to stay the same. Nothing changes over here. However, on this right side of the equation, I have a parentheses. I can't do anything inside the parentheses. I can't take away 1 from an x. I don't know what the value of x is yet. However, I can use the distributive property. And when I have a number outside of the parentheses, what that means is I want to multiply this number times each item inside the parentheses. So I'm going to multiply 5 times x, and then 5 times a negative 1. So 5 times x is simply 5x. 5 times negative 1 is a negative 5. And there we go. We're almost done. Now, as I said before, ideally what we want to do is to get slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So as you can see, we're almost to that form. I got a y out in front on the left side of the equal sign. I have a number in front of my x. And then I have the start of what's going to be my y-intercept, which is negative 5. It's not quite the y-intercept yet. So, third step. Put in slope-intercept form. We can do a lot more with an equation once it's in slope-intercept form. It's a lot easier to graph. It's a lot easier to tell what the slope is, what the y-intercept is. So, all right, to do that, the only thing that looks different from this equation and slope-intercept form is I have a minus 4 over here. In slope-intercept form, I don't have a minus 4. So what I want to do is I want to get rid of that minus 4. To get rid of something or move something, in algebra, we always do the opposite of whatever it's telling us to do. So here it says to subtract 4. So to get rid of that, we're going to add 4. That way I can cancel that out. Whatever I do to one side of the equation, I have to do the same thing to the other side. So I'm going to add 4 to both sides. That will cancel that out. Then I just bring everything down. I've got my y all by itself. I have a 5x. Now negative 5 plus 4 gives me a negative 1. And there we go. We've converted a point and a slope into slope-intercept form, and it's something that's a lot easier to graph. All right. That's one. Let's do another one. Let's do a situation where if we're not given a slope and we just have 2 points, then we got to find the slope first. Let's go to another screen. And we'll do one from the homework today, or classwork rather. Let's do number 6. Number 6 is 2, 6, and 4, 7. All right. So here, we don't have a slope. All we have are 2 separate points on the graph. So we got to solve for slope. So slope is nothing more than the change in y over the change in x. And you'll see it written as y2 minus y1, the change in the differences of the y, over x2 minus x1. So the difference of the y's over the difference of the x's. Now, it doesn't really matter which way you go. You can go right to left or left to right, as long as you're consistent. You can't go one way with the y and another way with the x. It has to be the same way. You'll come up with the same slope every single time. Since I have y2, and keep in mind that's an x value, that's a y value, an x and a y, I'm going to go over here first and then work my way backwards. So my y2, my second y is 7, minus my first y, which is 6. Then on the bottom for my x's, my second x is 4, and my first x is 2. Simple enough. We're solving for slope. 7 minus 6 is 1. 4 minus 2 is 2. So I have a slope of 1/2. Now, a lot of you are going to want to change this into a decimal. Don't. Especially when we're dealing with slope-intercept, we would prefer it be in a fraction form because this tells us our rise and that's our run. How many steps to go up and how many steps to go over. So, I now have my slope. All I need is a point. Wait a minute. I have 2 points to choose from. I can choose either point. No matter what point we choose, we're going to get the same exact answer. So, I will go with this point. Just because it came first. That's the only reason I'm going with it. Now, I'm going to go back to the same thing we just did with the last problem. Y minus y1 equals m, x minus x1. And I'm going to plug in the information that I have. Y stays minus. All right, my y in this case, since I'm using this one, is going to be 6. Equals, my slope is 1/2. My x value is 2. So all I've done here is I've plugged in my slope for m, I plugged in my y value for y1, and I plugged my x value in for x1. Make sure you're plugging them in the right location. All right, now the next step is to distribute. Because I can't do anything here. So this will stay as y minus 6. I can't do anything with that yet. We're going to move that over later. Now I distribute 1/2 times x and 1/2 times a negative 2. So 1/2 times x is nothing more than 1/2 x. 1/2 times negative 2, it's basically saying, okay, well, what's half of negative 2? Negative 1. So 1/2 of negative 2 is negative 1. Now we're almost there. Now all we have to do is move this 6 over to the other side. When we move it over, like I said before, we always do the opposite of whatever it's telling us to do. So here it says to subtract 6. We're going to add 6 to both sides. That 6's cancel out. And then I'm left with y equals 1/2 x. And then negative 1 plus 6 is a plus 5. I'll put it in like a little box so we know it's an answer. And that's how you use point slope. If you have any questions, please ask me in class. I'd be more than happy to answer your questions.